Okay, so this is section 2.6. The previous 2 days, we have learned how to solve a system of equations with graphing and substitution. And then yesterday was with elimination. Well, 2 days before, I guess, was elimination. And so this time, we are also going to be using elimination, but now we're solving larger systems. So remember whenever I said when we started this, however many variables you have to solve for, you need at least as many equations to get the job done. So if you have 2 variables you have to solve for, you need at least 2 equations with those 2 variables. If you have 3 variables that you need to solve for, you need at least 3 equations. Now, I've had to solve some fairly large ones in my time, but as big as we are going to get here are 3 equations with 3 variables. So I like the step-by-step directions here. So it says choose 2 equations in which you can easily eliminate a variable. Let's call this new equation after the elimination equation A. Then you eliminate the same variable. This is key. That's why it's bolded and capitalized. You eliminate the same variable from a combination of the equation you didn't use and one of the ones you did. So essentially, you have to eliminate a variable from 2 equations, then you have to eliminate the same variable from a different 2 equations. You can't use the same 2 you did in the first step, okay? And then we're going to call that equation B. Then it's like you start the problem all over again with equation A and B, and then you do the process of elimination or substitution all over again. So, clear as mud, right? Let's dive in and I'll show you what I mean. Looking at this example, just looking, again, my motto is work smarter, not harder. So which would be the easiest equation, maybe I should say, which would be the easiest variable that you could manipulate to eliminate from a couple of equations? Yeah, the single y. Definitely look at the coefficients on your variables, and if some of them are, you know, multiples of the other, that's an easy one. But obviously, if they don't have any coefficients in front of them, those are the ones I'm picking because that's going to be the easiest. Okay, so I'm definitely going to start off with these 2 equations right here. So I am going to, since I have a positive y and a positive y, one of them needs to be, yeah, negative. So I'm going to have to distribute a negative here. So let me just say I'm going to take this and take a negative through the whole thing. Okay? Every term is going to get a negative. So let me rewrite this. So first I have my 5x plus y plus 2z equals 10. And on bottom, I'm going to have negative 3x minus y plus 8z equals positive 28. Now, let me go back. I'm going to number these equations. This is equation 1, equation 2, and equation 3. So we used equation 2 and equation 3 here. I just rewrote. Now, if I add these up, again, what happens to my y's? My y's cancel out. So I end up with 2x plus 10z equals 38. Okay, that is my new equation A. Okay, that's what they referenced in that first step. It said choose 2 equations in which you can easily eliminate a variable, and then after you eliminate, call it equation A. So now we eliminated the y's. So now we have to eliminate the y's again, but using 2 different equations. We can't use 2 and 3 again. We have to either use 1 and 2 or 1 and 3. So looking, I'm just going to use 1 and 2, I think, just because they're next to each other. But if I use 1 and 2, what am I going to have to do to the second equation to get it to eliminate with the first equation? I'm going to have to multiply this sucker now by 6. Okay, the whole thing again. The 6 has to be distributed to every term. So let me rewrite. Again, equation 1 now is 2x minus 6y plus 9z equals negative 8. And then after I distribute a 6 through everything, I have 30x plus 6y plus 12z equals 60. Are we okay with that? Now, when I go to add these together, okay, again, my y's eliminate, negative 6y and positive 6y. So now I have 32x plus 21z, that's beautiful, equals 52. Are we okay? All right. Now, let's call this was step 2 from up above. Let's call this equation B. So now I am literally starting the entire process of elimination over again with just equation A and B. Okay, so let me stack B right under A here. So this is equation B. So I've got 32x plus 21z equals 52. Now, looking at these, it looks like x would be the easiest one to eliminate because 32 is a multiple of 2. Although it's a large one, it's a multiple of 2. So what would I need to multiply my equation A by to get the x's to eliminate? A negative 16. Okay? So I am multiplying this entire equation by a negative 16 so that it can eliminate with the B equation. So negative 16 times 2x is negative 32x. Okay, negative 16 times 10 is negative 160z. And again, I'm just going to do A underneath here. And negative 16, I'm whipping out the handy dandy calculator here. Yeah, negative 608, you got it. Okay, so now if I go and add these up, okay, just these two, okay, these are the two I'm looking at here. Okay, if I add those up, now my x's eliminate, right? So now I have 21 minus 160. I get negative 139z. Boy, that's beautiful. And then 52 minus 608. I get negative 556 for my constant. Now, if we divide then, okay, divide off the negative 139, that gives us z is 4. Now, all we have to do is back solve, is kind of what they call it, okay? So if you look at step 4 from up above, it says substitute your answers from step 3 into either original equation to find the remaining variables. And then we have to write our answer as an ordered triple instead of an ordered pair. So we are back solving now. So where do I need to put that z value in order to solve for y or z? Or sorry, y or x? Well, you may think so. Actually, it's going to be easier if you take this 4 and plug it into either A or B to solve for x. So we're going to plug it into A or B equation to solve for x. That's because the A and B equations only have 2 variables in them. So it's going to be a little easier. Okay? So for instance, on equation A, okay, if I'm looking at A here, I've got 2x plus 10 times 4 equals 38. Well, this is going to give me 2x equals negative 2 because 10 times 4 is 40. And then if I subtract it over, so then x is negative 1. Now I'm going to take this negative 1 and this negative 4 now I can plug those into one 2, or 3 to solve for y. So again, we're back solving. So you solve for your first variable, you plug it back into A or B to solve for the second one, then you plug those two back into equation 1, 2, or 3. Now, if we plug in, and let's just, I don't know that it matters. If we're plugging for y, let's use equation 2 here. Okay, so equation 2, we've got 5 times negative 1 plus y plus 2 times 4 equals 10. Sorry. I need to kind of block off what I'm doing here. So we're plugging in the negative 1 in for x, we're plugging in the 4 in for z, and then I've got my y in the middle. So negative 5 and 8, this is going to be y plus 3 equals 10. So y equals 7. Woo. So now my ordered triple, okay, I have now solved for all 3 variables. Be careful though when you write your answer, your ordered triple, okay, needs to be in order x, y, z. Always. Okay, so for us, that is negative 1, 7, 4. That is my final answer. And yes, these take a while, unfortunately. Okay, so again, pick two equations that you can easily eliminate a variable. Pick 2 different equations that you can eliminate the same variable. Then combine those 2 new equations together to eliminate and start solving. Okay, let's look at another one. Let's look at number 2. Let's just go down. So looking at all of these, I'm looking at my x's. I'm always on the lookout for what's going to be the easiest variable to start eliminating. So x's, at least 4, 6, and 2 are all multiples of 2. So that's something. They're all even. Y's, I've got coefficients of 1, 4, and 7. That's kind of ugly. And then the z's, I have 3, 3, and 11. I mean, the 3 and 3 would be easy. But then you'd have to do the 3 and 11. That would not be so easy. But really, you just have to multiply it one time. So I guess it would be okay. So it's kind of a crapshoot. I would probably either do the x's or the z's. So, Aiden, do you have a choice? Okay. So let's first combine these 2. Okay. If we combine these 2 to get our equation A. Okay. If we do that, now they're already, I've got a negative 3z and a positive 3z, so let's just go ahead and add those together. So my equation A is going to be 10x minus 3y. The z's are going to cancel, and then that equals 86. That is my new equation A. That was certainly easy enough. Okay. Now, equation B, I need to find using 2 others. So I'm actually going to use the bottom 2 for B. So let's use these 2 for my new equation B. So this, let me box it in here. This is my equation A. My equation B, what am I going to have to multiply the second equation by to eliminate the z's? By 11, and then the bottom one I'm going to have to multiply by 3. So I'm taking this one by 11 and this one by 3 so that my z's will cancel again. So to get my equation B, my new equation 2 is 66x minus 44y plus 33z equals 41 times 11 I'm having a brain fart. 451. I should have just done it in my head. And then on the bottom here, if I multiply the bottom times 3, I have 6x minus 21y minus 33z equals 85 times 3 is 255. Now, if I combine those together and add them up, again, my z's cancel, which is what I wanted to have happen. Okay, so then I am left with 72x minus 65y equals, what do we have here? 706. Now this is my equation B. Okay, so now I am going to combine A and B together somehow, some way. Okay, that's going to be gorgeous. In order to eliminate either the x or the y there. Okay, so what should, if we tried to eliminate, let's see, we've got a 10x and a 72x. Let me stack them on top of each other to start off with. So 10x minus 3y equals 86, and 72x minus 65y equals 706. So let's multiply the top one times, let's see, half of 72. Let's do 36 here, and let's do negative 5 here. We're going to eliminate x's. Okay, you could have done 72 and 10, but since they both, I'm just essentially taking the 2 out to make the numbers a little smaller. So the least common multiple here is 360. So now if I rewrite these, I'm going to kind of go to the left here. So this is going to give me 360x minus 108y equals 3096. That is after I distribute, again, this 36 to everything. Now, if I distribute the negative 5 to everything on the bottom, that is going to give me negative 360x plus 325y, kind of running out of room, equals negative 3530. Woo. Okay, so now, obviously, my x's cancel. Positive 360x minus 360x. Combine my y's together, negative 108 plus 325. I get 217y equals 3096 minus 3530 gives me negative 434. So then if you divide, you get y equals negative 2. Hallelujah. Yeah, that was, wow, I don't like those really big numbers. Okay, so how can we go about solving now? Well, what's the next easiest variable to solve for? Maybe I should ask that. The next easiest variable to solve for would be x, because we could put this answer into A or B. Plug into A or B to solve for x. Okay, so I'm going to plug that negative 2 into A or B to solve for x. Well, I'm picking A because the numbers are smaller. My mama didn't raise no fool. So we've got 10x minus 3 times negative 2 equals 86. So 10x plus 6 equals 86 10x equals 80, so of course x equals 8. Now, I've got the y, I've got the x. Now I need to plug x and y. I need to plug x and y into equations 1, 2, or 3 to solve for z. Okay, so just pick one. I'm just going to go with the top one. Okay, so we have 4 times my x is 8 plus my y is -2 minus 3z equals 45. So we have 32 minus 2 minus 3z equals 45. Okay, obviously 30. So if I subtract it off, -3z equals 15. So z equals -5. So my ordered triple, my final answer. Remember, you have to put it in XYZ form. Okay? Final answer is the ordered triple 8, comma, -2, comma, -5. That's my answer. Okay? Ordered triple. Now, could you check your answer? Absolutely, yeah. If you plug in your x, y, and z in all 3 equations, you can use your handy-dandy calculator to get that done. That's how you check your work. Okay, let's jump over and do application problem. Second page. Actually, I should say the front of the second page. Okay, number 6 here. The theater sells 3 types of tickets: general admission, senior citizen, and child. Mark bought 9 general admission, 2 senior citizen, and 3 child tickets and paid $170. Sarah bought 5 general admission, 4 senior citizen, and 7 child for $173, and Kyle bought 4 general admission, 1 senior citizen, and 6 child for $116.50. Okay, find the cost of each type of ticket. We need our 3 equations. First, let's define our variables. So I'm going to say x equals general admission. Okay, I'm going to say y is senior citizen and z is child. Okay, and we're talking number of tickets. Okay, actually no, not number, we're talking price of tickets. Okay, so we're talking price here on the x, y, and z. So first equation, it's just going to go sentence by sentence. Second sentence, third sentence, fourth sentence gives us our 3 equations. So we have 9 general admission, that's 9x. 2 senior citizens, 2y. 3 child, that's 3z, and it equals 170. 5 general admission from Sarah, 5x plus 4y plus 7z, 173. And Kyle, we have 4 general admission, 4x, 1y, and 6 child, 6z equals, oh great, decimal, 116.50. Okay, these are my equations 1, 2, and 3. Now again, I need to eliminate one of the 3 variables from 2 equations. Which variable would probably be the easiest to eliminate? Looking at the coefficients. The y's, definitely. Because 4 is a multiple of 2, and here we just have a plain y with no coefficient. Well, it's actually a coefficient of 1, of course, but y is definitely going to be the easiest one to eliminate. So let's first combine, let's combine the first and third for my A equation. And in order to do that, I'm going to multiply this third one by a -2. Okay? So let me rewrite those over here. So I've got 9x plus 2y plus 3z equals 170. And then if I multiply the bottom equation by a -2, that gives me -8x minus 2y minus 12z equals 11650 times 2 is 233. Now, if I add those up, again, the whole purpose here was my y's are going to cancel. So that's going to give me 1x minus 9z equals 403. Okay. Are we okay so far? Yep, so this, again, is my equation A. Let me label it here and box it in. So now we have to eliminate the y variable again, but from two different equations. So why don't we do 1 and 2 this time? So let's combine 1 and 2 this time for my B equation. And when we do that, I'm going to have to multiply the top equation then by a -2. So that I have a -4y and a +4y. You still with me? Okay, so let me again write this out over here. So my new number 1 equation is going to be -18x minus 4y plus 3z equals -340. And my number 2 equation right under it, 5x plus 4y plus 7z equals 173. Okay, now add those up. This is my B equation here. Again, my y terms are going to cancel. So I'm going to be left with -13x, plus, oh, you know what? I screwed up on the top one. I didn't distribute my -2 to my 3z. That should be -6z. Do you see my error? This should be -6. So -6z and then -340. That makes a lot more sense. So I've got -13x, plus 1z equals 340, well, -340, and a +173, -167. Okay, so now this is my equation B. Okay, equation B. Okay, so now I've got equation A and equation B that I need to combine together. Let me write them on top of each other over here. So I need to eliminate more variables. So I have x minus 9z equals 403, and I have -13x plus z equals -167. So it's kind of 16 one way, 12 one way, dozen another. Do you want to eliminate x's or z's here? Z's. So that means we are going to have to multiply the bottom by 9, right? So I'm just going to move this over, copy it. X minus 9z equals 403. Okay, down here, 13 times 9 gives me a -117x. And then plus 9z equals 9 times a negative 167 is negative 1,503. I got some big numbers here. Okay, so now my z's cancel, which is what we wanted. So I've got negative 116x equals 403 minus 1503 gives me that, divided by, did I screw up somewhere? I'm not supposed to get a decimal. So let me go back and see where I messed up. Obviously, teachers screw up too. Top one, let's see if I screwed up that. -4, -6, 340. I'm not seeing it. Aiden, are you seeing my mistake? I'm not seeing. Oh, I see it now. I see it. It's way back here. This should have been a negative. So that would change this value here. Okay. See, this is real world, people. This is when you screw up. There we go. Okay. Now we're cooking. That should have been a negative 233 because we were distributing through the -2 on equation 3 down there. So then that changes. Oh gosh, my eraser is probably going to screw this up. Oh, not sure what happened there. Oh my goodness. Okay. I don't know what my smartboard's doing. It's kind of possessed. This should have been a -63, and this is -167. Holy smokes. Okay. Let's see if I can change this whole thing now. It's not letting me now. Oh, goodness gracious. Okay. This then is -63. So that's going to change this number. Then we're going to be cooking. Okay. Holy cow. So 63 and 1503 negative this, then divide by 116. Okay, x is 13.5. Hallelujah. Okay, see, now you know your teacher screws up too. It is human error. All right, not sure what did my smartboard possession over there where things were moving around, but I hope you all can see where my screw up was there. I distributed the 2, I didn't distribute the negative, which changes everything. Okay, so now that we have x is 13.5, where do we go with it? Yeah, we can put it in A, we can put it in B, it really doesn't matter. But let's go ahead and put it up here. So we've got 13.5 minus 9z equals -63. Okay, so -63 minus 13.5, if we pull it over, we've got -9z equals -76.5. So that divided by z is 8.5. Okay. Ooh. So now we've got z is 8.5, x is 13.5. How do we get y? Yeah, now we plug the x and the z into one of our first three equations to solve for the missing y. So I'm just going to plug it in the top one. So 9 times 13.5 plus 2 times y plus 3 times 8.5 equals 170. Okay, so I'm going to have 2y plus, I'm going to go ahead and combine these. So 9 times 13.5, and I'm going to go ahead and add that to 3 times 8.5, and you get 147. That equals 170. Okay. So if we move the 147 over, we have 2y equals, 23. Okay, so y equals 1150, 11.5. So we have x is 13.5, z is 8.5, y is 11.5. So our costs per ticket, okay, let me write them over here. Cost per ticket. Our general admission. What variable was that? That was our x, so that was $13.50. Okay. Our senior citizen. That was our y, so that was $11.50. Okay, sorry, old habit, I always underline the decimal part when I'm doing money. Back in my accounting class days, we did that. And then child ticket is $8.50. Okay. Woo. Sorry for the screw up earlier, but I think you guys understand. That is why we do math in pencil. It's not quite as easy to erase on a smartboard. But, okay, so you have an example of an application problem. 2 other problems. You only have like 4 questions on your homework today. So, that's it.